Hello everyone. Today we are going to start off with the new chapter. We are going to talk about a physical quantity which is used to stop a moving body or which is used to start a body which is at rest. For example, the book is at rest. Is it moving? No. So if I want to move it, what I have to do? I have to apply something. So that something is nothing but force. So we are going to study about the concept of force. Force dynamics means the study of cause behind the motion. Motion means what? We are talking about moving objects. We are talking about distance traveled, how much speed it is going, what is the time taken, all these things. But we didn't talk about what is the cause behind that motion. Something is pushing that particular object. That something is nothing but force. So dynamics means the study of cause behind the motion is called as force. Now, what are the effects of force? Force can be used to crumble a paper or it is used to tear an object, whatever it is. Effects of force. It can change the state of rest or state of motion of a body. As I said, this book is at rest. Now, I want to move it. I am applying some force to move the book from rest. Now, the book is moving. I am applying some force to stop it. So, force can change the state of rest or motion of a body. Next, force can change the shape of a body also. If you are taking a roti dough or chapati dough, what will happen if you flatten it? It is going to become a circle. Okay, you can change the shape of a body. If you take a paper, you can crumble it. So what will happen? The shape of the paper will be changed. Force can change the direction of the body. Okay. Then force can change the speed of a body. You generally see this direction of a body while driving the vehicle and speed of the body while driving the vehicle. Or if you are playing some cricket or football, what happens when you give a good kick? It is going to change the speed of that particular body. Now, what is meant by force? See the definition. The physical cause which changes or tends to change either the size or shape or state of rest or of a motion of a body. This entire definition will give you the effects of force also. Now we shall see what are the kinds of forces. There are two types of forces, contact force and non-contact force. Contact force means which will make the force. Contact force means which is directly applied on an object, where the force is directly in contact with the object. For example, you have muscular force, that means force acted by muscles. That means either you're brushing of your teeth or writing with your pen, whatever you're doing with your muscles, lifting up a weight or whatever it is, you are doing with muscles. The second category is frictional force, the force that opposes the motion of a body. For example, application of brakes of a car. For example, the car is moving on the road. How will you stop it? You are going to apply the brakes. The brakes is nothing but frictional force which is opposed by the road. Now, next one is normal force. Normal force means supportive force of a body. For example, this pen cap is in my hand. I have given a support directly with my hand to this particular pen. Okay, this pen cap has a support. Now what happens? If I remove my hand, what will happen to the pen cap? I have removed it. What happened to that pen cap? So it has fallen down. So initially it was in contact with my hand. Once I removed it, what happened? The pen cap has lost the contact from the pen and it fell down. It went into the non-contact force. Normal force means the supportive force which is acting at 90 degrees. For example, if you are taking this as a table and you kept a block on it, the block is supported by this table. As I said, if you remove the table, what will happen? The block will fall onto the ground. Just like how the pen cap has fallen down. Now see the angle between the block and the table, it is exactly at 90 degrees. So normal force means the supportive force which is acted upon by that particular object. If you are sitting on the bench, that bench is giving you the normal force. Okay. The next category of force is tension, that is extension capability of a string or a spring. For example, if you are taking a rubber band, what will happen? This is the normal position of the rubber band. Now I am going to stretch it. Now I'm going to stretch it. Okay, how much it can be extended, the capability depends upon this rubber band. Now I'm going to leave it. What happened to the rubber band? Again it has come back to its original position. It is restoring its original position. Now the second case, I'm crumpling the rubber band. I'm leaving it. What happened? It has restored its original place or original shape. So this is nothing but the tension, extension capability of a string or a spring. For example, there is a rigid support and you are hanging a weight, a piece of block, you are hanging it. What is happening? This string will be stretched. This is the tension developed in the string. This string is holding this particular block. Now this weight, the weight W of the body pulling the string, this weight of this particular body is pulling the string. How much it can pull depends upon the tension developed in the string. Suppose if you are taking this support of the string like this, okay, if it is a 10 kg, it will be like this. For example, you are increasing the weight to 50 kgs. Now what will happen to this string? It will elongate. Okay, still if you are making it, now if I am taking the weight as 50 kgs, see what happened to the string? It has extended more. Now if I am making it 150, what will happen to this string here? Again it is going to stretch. So the stretching capability is increasing as the weight here is increasing. So coming to this point, tension is nothing but the extension capability of the string. This is a very, very important category. Now coming to the second category, non-contact forces. That means this force is not in direct contact with the object. First one is gravitational force. Just now I said, if I am taking this cap, now it is in contact with my palm. If I am leaving it, what will happen? It has fallen down. What is that non-contact force which is acted by this on this particular thing? It is nothing but the gravitational force. The force with which the earth is attracting, it is pulling this particular pen cap towards its center. This is a gravitational force. Second category is electrostatic force. That means the force of charges produced. For example, if you take a comb and when you rub it on your dry hair and when you bring it near the tiny pieces of paper, what will happen? These pieces of paper will get attracted towards the comb. That means this comb is getting charged and that charge is trying to attract these tiny pieces of paper. This is the second category, electrostatic force. That means static electricity is developed on the comb when you are rubbing it on your hair. Third category is magnetic force. That means the force which is acted by the magnets. If you are taking two magnets, you know a magnet has two poles, north and south. One more magnet, south and north. Now what type of force they will have? They will have an attraction force because this is north and this is south. For instance, if you are taking this one also as north and this one as south. So what type of force it will have? They will have force of repulsion. What will happen? These two magnets will be repelled from each other. So these category of forces are also called as field force. Here the field which is acted here is gravitational field. And here electric field is acted. And here magnetic field is acted. Field means the area around which that particular force is acting. Here in this particular area magnetic force is acting. Now if I am leaving this pen cap, what will happen? It will fall down. That means this particular area has got gravitational field. Similarly, when you are combing it, what will happen? The area here is the electric field which is acting. So these are the categories of forces. Now we shall see what are balanced forces. When the total force acted on a body is 0. For example, this is the body. From this side a force of 5 newtons is acting and from this side 5 newtons is acting. That means when equal forces are acted upon a body, then the body does not move. So what will happen? The total force acted upon that body will be 0. That means this force is balanced. If you are talking about unbalanced force, when the total force acted upon a body is not 0. For example, if you are talking about this body, a force of 6 newtons is acting from this side and from this side a 4 newton is acting. So what will happen to the total force? 6 Newton minus 4 Newtons, that is 2 Newtons. See the direction of the arrow, that means the object will move towards this side, because here more force is pushing this body towards this side. So the arrow is from this side. 2 Newtons extra force is acted on the particular body. Example 2. You are taking a body and a force of 10 Newtons is acted from this side and 14 Newtons is acted from this side. F net, that means net force, that is total force acted is 14 minus 10, that is 4 Newtons. So this is more. 4 Newtons is acted upon this body and the box is pushed towards the left side. See the arrow here? So force is a vector quantity. How much amount of extra force is acted by this particular body? It is pushed towards that side. So that is 4 Newtons towards that side. Now we shall see what are the units of force. CGS units of force is dynes. SI units of force is Newton. And the relation between dynes and Newtons is 1 Newton is equal to 10 power 5 dynes. This is about balanced and unbalanced forces. Now coming to the pressure, force acted on a unit area. For example, I am trying to some force on this particular area. That means I am applying some pressure on this particular object. So pressure is equal to force by area. CGS units of pressure is dynes by centimeter, because force is dynes and area is centimeter square. SI unit of force is SI unit of pressure is SI unit of force is newtons and SI unit of area is meter square. So SI unit of pressure is newtons per meter square. Note, pressure is inversely proportional to area. If area of contact is less, the pressure will be more. If the area of contact is more, the pressure will be less. For example, if you are talking about a sharp pointed pen, okay, now I am taking this particular palm. If I am trying to press my palm with this blunted part, what will happen? The pressure acted on this particular body is less. But if I am talking this sharp pointed one, if I am trying to press it on that particular same area, what will happen? This will go deep. That means the pressure acted upon this particular area will be more. That means sharper the contact of area, the deeper the pressure. Example, sharp knife is used to cut the fruits. We cannot use the blunt knife to cut the fruits, because blunt knife means the area of contact will be more, fruits cannot be cut. So we are going to use a sharp knife. Sharp knife means the area of contact is less, so the pressure will be more on the fruit and you can easily cut that particular fruit. Second category of pressure, liquids exert pressure. This here we are talking about the solids. Now we are talking about liquids. Liquids also exert pressure. If you are taking a vessel of water and I kept 3 holes at equal depth, same depth, what will happen? Equal amount of water, equal pressure will be coming out. The pressure of the water will be equal from all the sides, equal pressure at equal depths. Now second category, here I have taken 2 holes, one is here and the other one is here. Which one is having more pressure? The second one is having more pressure. It is going to a larger distance when compared to the first one. So liquids exert pressure. Liquid pressure increases with the increase of depth below the free surface. As the depth is increasing, the liquid is moving to a longer distance when compared to the lesser